continuing from where we ended the other day. So this one, we're talking about properties of operation on rational numbers. And then the first property we talk about is commutative property. Commutative property. Okay. And then we are going to use these signs or these operations. We use addition, subtraction, multiplication, and then division. These are the operations that we will use throughout. And then we call these operations binary operation. Binary operation. Simply because when we operate, we use them to combine two numbers together to get another number. Let's say 2 plus 5 give us 7. 2 times 5 give us 10. So whenever we use this number, we operate it on another number and it gives us another number. That's what we call them binary operations. So let's talk about commutative property. In the commutative property, you can say that if A plus B is equal to B plus A, then this property is called commutative. Let's take example here. If you have 2 plus 5, and we can write the same as 5 plus 2, then the property is commutative. And then if we add this, we get the same answer as we add this. That's what we say it's a commutative. So say 2 plus 5 give us 7, 5 plus 2 give us 7. So we say it's a commutative property. So the first thing that we can say that addition is commutative. Addition is commutative. Let's also try on multiplication and see. If A times B is the same as B times A, then we can conclude that this is commutative property. Let's take example and see here 5 times 2. If this is the same, the result that we get here will be the same as 2 times 5. Then we can conclude by saying that multiplication is also commutative. So let's see. 5 times 2 give us 10. 2 times 5 also give us 10. So we can conclude by saying that multiplication is commutative. Please, one thing that we should know about commutative is that subtraction and division are not commutative. For example, let's say something. A minus B is never the same as B minus A. A minus B is never the same as B minus A. So let's try something and say, if I have 5 minus 2, let's say if you can get the same matching as 2 minus 5. 5 minus 2 give us 3. This 2 minus 5 give us minus 3. So we say that they are not commutative. So we say this subtraction is not commutative. Let's try division and see. If you have, let's say, 20 divided by, okay, let me just go by this one and write this one very well. Let me just say A is not equal to B divided by A. Okay, so let's see something here. If you have 20 divided by 10, will you get the same answer when you divide 10 by 20? And the answer is no, because 20 divided by 10 will get 2, and then 10 divided by 20 will get 0.5 or half. So they are not the same. So we say that division is not commutative. Let's move on to the second property we call the associative. The associative property. Okay? The associative property. In associative property, let's say that we have three numbers, A, B, and then C. If you can say that A plus B plus C will give us the same answer as A plus B plus C, then we conclude by saying that this property is called commutative. Example, let's say you have 2 plus 3 plus 4, and then we also have 2 plus 3 plus 4. All that we know is that board mass, we have to operate the one in the bracket first. So have 2 here plus operating this one in the bracket, you get 7. So 7 plus 2 give us 9. Let's see this one. Operate the one in the bracket first. This plus this one give us what? 5. So write 5 here plus your 4 here give us 9. So we can say that they are all the same, and this type of operation is called associative. So we can conclude by saying that addition of rational numbers, addition of rational numbers is associative. Okay, let's try for multiplication and see what we get. Let's do the same thing that A and B and C are numbers. So you can say that A times B times C is equal to A times B times C, like this. We conclude by saying that it's associative. Let's see something here. We are having, let's say, we are using 2 times 3 times 4. Okay, should be equal to 2 times 3 times 4, like this. So it means that when you multiply the whole of this one, we should be able to get when we multiply this one together. So this time this one will give us 6 times 4 equal to, this time this one will give me 12. So 2 here times 12. 6 times 4 give me 24. And then 2 times 12 give me 24. So we can conclude by saying that multiplication is associative. Okay. So note, one thing that you should also know here is that subtraction and division are not associative. They are not associative, no matter what. Let's move on to the last one. Okay. Alright, so we are finishing on the properties, and then the last one is distributive property. And with the distributive property, we normally use, let's say, CA, B plus C, and then if you can expand this bracket and we get AB plus AC. This is what we call a distributive property because we've been able to distribute A over B and A over C. So we say that in conclusion for distributive property, we say that multiplication is distributive over addition. The same thing when we have, let's say, A to bracket B minus C, we can get this one AB minus AC, and we can say that multiplication is also distributive over subtraction. So actually the distributive property is when we are able to distribute a number over another. So this is all about the distributive property. So don't say it. Okay, so we want to finish on a closure property. So the closure property is actually when an operation is operated on a particular set, the element of a particular set, and then after the operation the results belong to that set, then we say that that set is a closure. So it means that you not get different elements after the operation has been done, and that's called closure property. So let's look at this example very well. If the operation plus is defined over the set S is equal to 1, 2, 3, 4, and then there's been shown me that you can add any of the numbers in the set, but we can see that after adding 2 and 3 we get 5, and 5 is not in this set S, so we can say that set S is not a closure because we have an element after the operation which is not in the set.